All right, so this is 5.1, graphing inequalities on a coordinate plane, part 2. So the first part was all the inequalities were like in y equals mx plus b form. They're very easy to graph. But now what do we do when it's in standard form? Okay, so standard form, okay, we're not going to treat it any different. We're going to view it as like x plus y equals 5. And we're going to be using the cover-up method. The only thing that changes a little bit is how are we going to determine which side of the line to graph. And this is where the test point really comes in handy, AJ. Okay, so if you can recall the cover-up method. So if we cover up x, we have y equals 5. Do you guys see that? Y equals 5. I know it's in inequalities, but y equals 5. Do we see that? So everybody put a point at 5 on the y-axis. Now we're going to cover up the x and we have, or the y, and we have x equals 5. So we're going to put a point there. Now we have our 2 points, and we need 2 points to make a line. A couple things we need to look at. First one, the easiest one to deal with is that sign. It means dotted or dashed. So we're going to come through here, and we are going to make a dashed line. And now you can see that my graph is divided into 2 sections. We have an upper right and a lower left. Does everybody see that? And to determine which side we are going to graph, okay, we pick a test point. And if the test point holds true, we shade on that side of the graph. If it's false, we shade on the other side. So the test point I always try to pick is 0, 0. So this is my test point, because if I'm picking the point 0, 0, it's easy to add zeros and multiply by zeros, right? Because things just kind of go away. So we label our point and we just plug it in. Is 0 plus 0 greater than 5, Lamb? No. So do you see how this test point failed and it's below my line, so to say? So we shade on the opposite side. Okay. Any questions with that? So the first way to go about graphing in standard form is to really just try to do the cover-up method. Okay. So we want to look at it. In this one, I could obviously do the cover-up method. Now, in example number 2, if I'm looking at this, okay, if I cover up x, I have y equals -3. But if I cover up y, I have 2x equals -3. And they don't play nice. They don't divide out. So what I have to do is I actually have to get y by itself in this case. So I would simply subtract 2x from both sides. And that gives me y is less than or equal to -2x minus 3. A couple of things we need to be aware of. Okay. First thing, all right, and the most important is when we divide by a negative, we have to flip our sign. Okay. Now this one I didn't have to divide by a negative, but if there was a number in front of the y, I might have to divide by a negative. So we have to keep that in mind. All of the rules of inequalities still apply. We need to get y by itself through adding or subtracting the x, then multiplying or dividing in front of the y. And then we have to make sure if we divide by a negative or multiply by a negative, we flip that sign in the middle. So here, now that it's in y equals mx plus b, we're going to start here at -3. And then this says to go down 2, right 1. So notice again, I go off the graph. I went down 2, 1, 2, to the right 1. So my line is going top left to bottom right. So I need points over here to the left. So I kind of work backwards. How do I get from this point to this point? All right, I would go up 1, 2, and to the left 1. So up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Do you see how my points all look in a line now? So from here, I'm going to look at my sign. This says it's solid. I'm going to come through here. Make my best solid line. And now I can either use the test point method of plugging in 0, 0, which I actually like doing better in this case, because if I made a mistake in solving for y, at least I'll shade hopefully on the right side of the line, okay? In terms of that, I mean, either you're shading above the line or below the line. So we could take the test point of 0, 0, plug it into the original equation, is 2 times 0 plus 0 less than or equal to -3. Is 0 plus 0 less than -3?
No.
No. So we would shade below, which also matches up with we're not eating the y here. Do we see that? Because we're not eating the y, we're shading below that line. How are we feeling about this? Pretty good? It's not terrible, right? Not terrible. Okay. This one, what method would I want to use for example 3? Would I want to solve for y or would I want to do the cover-up method? Drew, what do you feel? Okay. So Drew wants to solve for y, right? I probably would have done the cover-up method real quick, but it's okay. We can solve for y. All right. So if we're solving for y here, I'm going to go ahead and subtract 2x. That gives me 2y is less than or equal to -2x plus 4. And then I divide by 2. So I would start at 2. It says to go down 1 to the right 1. Okay, so I would have gotten all those points. Notice, Drew, if we decided to do the cover-up method, we would have covered up the x and gotten 2y equals 4. Divide by 2, you get y is 2. Notice I have a point right there. If I covered up the y, I would have 2x equals 4. Divide by 2, we have x is 2. And I have a point right there, and I would have been able to cover them up pretty quickly. All right, but there is no wrong way. Sometimes the cover-up method works, sometimes it doesn't. From here, I'm going to draw a solid line. And Emma, which side of the line am I going to shade, above or below? If you need a second, take a second. Okay, we have it in y equals 4. So we can always look at that sign and determine, are we eating the y or are we not eating the y? That'll help me to figure out where to shade. Or you can take, and if you're taking a test point, since we're not going through 0, 0, I would plug in 0, 0 into my original equation to see if it works. So take a second, Emma, and let's go from there.
Above.
You said above?
Emma, did you say above?
Yeah.
Okay, how'd you get above? Which method did you use? Did you plug in 0, 0, or did you look at the symbol?
Yeah, I plugged in 0, 0.
Okay. So what's 2 times 0, Emma?
0.
Plus 2 times 0.
Still 0.
Is that less than or equal to 4?
Yeah.
So since it held true, we shade on the side of 0, 0 since that point worked. So we're actually going to shade below. Do you see that, Emma?
Yeah.
Okay. All right. Nate, what method do you want to use for example 4? Do you want to do the cover up or do you want to solve for y? Maybe he went to get a, snack. Maybe, from Linvilla.
One day I'm not even weird.
Nope. Won't happen. Am I? I don't think I am.
I think you should get extra credit.
Extra credit? What do you think this is? Whose line is it anyway? Points are just made up.
Yes, I know. What about extra credit if you see her?
That might happen.
Or become April 2nd to see Mr. Harmon.
Do like some pony rides. All right. Kevin, which method would you use? Would you use cover up or would you use solving for y? I can't wait till everybody's back. It's gonna be so much fun. There'll be nowhere to go. Yeah. You're gonna say, no, I'm not gonna participate. I'll just keep calling on you until you do. How it works. Fine. So, what do you want to do?
Well, I tried to do the one where you not cover the other one.
Okay.
But then
All right.
it was like -2 divided by 3.
Okay, so you did. So you got to here, right? And then you divided by 3, right?
Yeah, they said like 10.
But here's the beauty of doing it this way. We don't have to do anything with the slope. Remember, slope's a fraction. So when you get it to this point, I don't need to get a number for that. I just want it to be a fraction. It could be the ugliest fraction in the world, like 7/12. It's still a slope. I can still count down 7 blocks and go to the right 12 blocks. So this is fine. 6/3, this is the number you want to be like a whole number. So 6 divided by 3 is 2. And now we're going to start at 2. And then we're going to go down 2 to the right 3. Okay. And it's going to be a dotted line. And are we shading above or below? Above. Because we're eating the y. If I were to take my test point of 0, 0, and I plugged it in, I could do 2 times 0, that's 0, plus 3 times 0, that is 0. And is 0 greater than 6? The answer would be no. And then I would shade above that one. Does that make sense to you guys? Wife's texting me. She knows better not to disturb you in the middle of math. You get very grouchy. All right. Hope. You ready for this?
Yeah.
You sure?
Yeah.
All right. You better be because I'm letting you use my charger. Okay, and it's on YouTube, so we can't take that back. Okay. The solution of a linear inequality in two variables is an ordered pair that makes the inequality true. So there's going to be a lot of solutions, okay? There's going to be a ton. And that's why we shade. Does that make sense to you? So any point in that shaded region is a solution, okay? So it says determine whether 0, 0 is a solution of the inequality. Okay, now there's two ways to do this. Okay, first way, we could do it algebraically. Okay, here's what it looks like algebraically. All right. We have y is greater than negative 2x minus 4. And we have our test point of 0, 0. So algebraically, we label our point, and we're just going to plug it in. Is 0, I'm asking, is 0 greater than negative 2 times 0 minus 4? And we have 0, all right, being greater than negative 2 times 0, that's 0 minus 4. And is that true? Yes or no? Is 0 greater than negative 4? Yeah. Yeah. So we would have that 0, 0 is a solution. Okay? That's algebraically. Graphically, I like it a little better because I could ask you a ton of different questions from it. So here we would start at negative 4, 1, 2, 3, 4. And then I would go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, that's dotted. Okay, and we're going to be shading above. So here's why I like the graphing a little bit better. Algebraically works great in a pinch, but here's what's nice about this. Does everybody see the point 0, 0? Right? See how I made a big green dot at 0, 0? Do you see how it's in that red shaded area? That's a solution. If I ask you, is, say, negative 3, 4 a solution? Well, if you're doing algebraically, you'd have to plug it in. But graphically, Jordan, we would go to negative 3 on our coordinate plane and up to 4. Am I in the red shaded region? Yeah. Okay, if I asked you, is 1, 10 or 1, negative 10 a solution? So I'd go to 1 and I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that in my shaded area? No. So when you graph it, you can see if multiple points. Algebraically, you got to keep plugging in one at a time. All right, you guys try this one. Graph it. So use negative 1, 9 in the shaded area. And then I also want you to do it algebraically. All right, when you get a chance, look up the board. I did it algebraically off to the right. So you can see I just labeled the point, plugged it in, asked myself, that's why I have the question marks. Is -2 + 9 greater than or less than -3? No, it's greater than. So I came over here to the left on the graph. Okay, I couldn't do it using the cover-up method, so I had to get y by itself. I did that. That's the work up to the top left. I plotted my points, connect them with a dotted line. It said y was less than, so I shaded below. And then I plotted the point 1 or -1, 9. And notice it was outside my shaded area, so it didn't work. Any questions? No? We okay? All right. So you guys have 2 questions. I want you to do them. And then when you are done, okay, I believe there's an IXL, I think it's called T3. I'll pull it up real quick. T3 that I want you guys to get working on. It's about graphing, okay? And I will post the tutorial if I have it. So I'll give you guys a second to do that.